Panas. Saya nak minum. Panas sebab. Okay, so Assalamualaikum warahmatullahi wabarakatuh and good morning everyone. So firstly, like usual, we need to test the mic, we need to test the screen, we need to test the sound. So how was everything? Is everything good? Okay, good. So Zaihusna said good. So let us proceed then. Okay, so this is the third lecture for matrices and system of linear equations. So basically we should be able to finish chapter 4 by this week. And then next week we will start with a new chapter, chapter 5. Okay, next. Right, so the subtopic. So for today, we are going to do 4.3 inverse matrices. So we have done the types of matrices. We have calculate the determinant of matrices, where we learn about how to find the minor cofactors and then how to calculate the determinant by using cofactor expansion of cofactors. Okay, so today we are going to proceed with the inverse matrix. Okay, so the learning outcome, compute the inverse of a non-singular matrix using adjoint method. So today we are going to look at the adjoint method and then one more actually the property. Okay, so what does it mean by non-singular matrix? Oh lah, terpadam dah lah. Non-singular matrix. Okay, so non-singular is when the determinant is not equal to 0. So determinant of A cannot be equal to 0 for a non-singular matrix. Singular matrix, that is when determinant of A is equal to 0. So basically, if determinant of A is equal to 0, then we say that A is not invertible. Nak sebut pun payah. Invertible. That means you cannot find the inverse of A. So A inverse does not exist. Ni senang sikit kot nak faham. Payahlah yang ni nak sebut. Sebut ni lah, A inverse does not exist. Okay, so if the determinant is not equal to A is not equal to 0, determinant of A is not equal to 0, then A inverse does exist. And we do have the formula, the way to calculate the A inverse. Okay, so how to find the A inverse? So basically, A inverse, you have three methods to calculate A inverse. You can use the adjoint method. So this is the first one, adjoint method, where A inverse is 1 over determinant of A adjoint of A. So this is the reason why determinant of A cannot be equal to 0. Because basically, if the determinant of A is equal to 0, then you will have 1 over 0, which is undefined. So that's the reason why we have to be very strict, where the determinant cannot be equal to 0 if we want to calculate the A inverse. The second one is by using the property AB equal to KI. So we are going to go through this one later on. And then the third one, the elementary row operation, ERO, where from the augmented matrix AI, we're going to change it after some row operation, we are going to change them to I and then A inverse. Okay, so now you might be wondering, why do we have to calculate the A inverse? Why? Sebab dah tak cukup banyak benda dah ke nak kena calculate? Kenapa kena calculate A inverse? Okay, so this is why. Okay, basically, if let's say you have algebra, right? So you have AX equal to B. So if I say make X as the subject, you are going to do X equal to B over A. But this is in algebra. So this is possible in algebra because you can actually divide them by A. However, in matrices, we cannot have a matrix divide with another matrix. So that is the reason why you have to use the A inverse. Okay, so if let's say you have AX equal to B, in order to get the value of x, you have to do A inverse. You need to times with A inverse. So A inverse AX equal to A inverse multiplied with B. So x is equal to A inverse multiplied with B, because A inverse times with A is simply equal to identity matrix between 1 0 0 0 1 0 0 0 1, which is I. So I kalau darab dengan X dapat X balik lah. Okay, so this is actually the motivation. Why do we need to learn about the A inverse? Sebab bila kita nak cari yang macam X macam ni, kita akan ada masalah sebab dalam matrices tidak membenarkan pembahagian. So kita tak boleh bahagi, kita boleh darab dengan constant. Tapi kita tak boleh bahagi dengan matrix. So method yang kita guna dalam algebra doesn't work over here. So that's the reason why you have to know how to calculate the A inverse. Okay, so let us go through the first one, Adjar Method. Oh, 2 by 2 first. Just a bit of recap. Inverse for a 2 by 2. If let's say A is equal to A, B, C, D, then the A inverse is 1 over AD minus BC, where this one is actually the determinant of A, and then you times with D, negative B, negative C, and A. So for A and D, we are going to change the place for them. So kita akan tukar tempat untuk D dengan A. But for B and C, we are going to times them with negative 1. Okay, so let us do the same for the example. Find the inverse for A. A is 3, 1, 5, 4. Okay, so the formula for A inverse, so this is 1 over determinant of A, and then I have to times with D, A, negative B, negative C. Nampak ke? Boleh kot. Okay, so now we need to calculate the determinant first. How to calculate the determinant? The determinant is AD minus with BC. So determinant is 3 times 4 minus 1 times 5. So AD minus with BC. So we got 3 times 4, 1 times 5. So we got 12 minus with 5, which is exactly equal to 7. Okay, so once you have your determinant, then you can easily substitute into the formula for the inverse. Okay, so this is the formula for the inverse. Substitute the determinant, which is 7. And then flip for A and D. Change the place for A and D. So yang ni A dengan D tukar. And then for B and C, don't forget you have to times them with negative 1. Okay, so this is A, this is D. I'm going to flip them. So that is why 4 is at the top, 3 is at the bottom. And then we have to times with negative 1 for 1 as well as 5. So negative 1, negative 5. And then what do we do next is that we should times the constant inside the bracket. So they will become 4 over 7, negative 1 over 7, negative 5 over 7, and then 3 over 7. So quite easy, right? For a 2 by 2. Okay, so 2 by 2 dia memang simple sikit lah. Dia tak complicated sangat for a 2 by 2. Okay, done. Let us proceed to the inverse of the 3 by 3 again. Okay, so now we are going to learn about the adjoint method. So this is basically the formula that we are going to use. So firstly, A inverse is 1 over determinant of A, adjoint of A. So what is adjoint of A? So adjoint is quite new because we haven't learned before in 4.2. So adjoint is actually equal to cofactor transpose. So what does they mean is that you have to find out what is your cofactor matrix. And then from that cofactor matrix, you should transpose them to become adjoint. Okay, so it's like this. So to calculate the inverse, I have to calculate what is the adjoint. To calculate the adjoint, I have to find what is the cofactor. Transpose, cofactor, transpose. To get cofactor transpose, this simply means that I have to find the cofactor. To get the cofactor, that simply means we have to start with the minor. So that's the smallest one. So we're going to start from the minor, and then we are going to proceed to find the cofactor, and then we are going to transpose our cofactor to get the adjoint, and from the adjoint we are going to substitute into the formula to calculate the A inverse. Does that make sense to you? Okay ke? Boleh. So I repeat. Okay, so the formula is using adjoint. Okay, so we want to find A inverse, but to find the A inverse, I have to calculate the adjoint. So what is adjoint? Adjoint is actually cofactor transpose. So if I want to find cofactor transpose, I have to know what is the cofactor first. In order to find the cofactor, I have to know what are the minors for the matrix. Okay, so now let us find what is the minor, cofactor, cofactor transpose, and then adjoint, and then A inverse. Okay, next. Okay, so given that A is 1, 2, 3, 3, 2, 4, 1, 1, 3, find the adjoint of A. So we have to find the adjoint of A. Okay, so like I told you before, adjoint of A, that means we have to find the cofactor transpose. So to find the cofactor transpose, we will need to have the cofactor. To get the cofactor, we have to start from minor. Okay, so let us calculate the minor of A. Okay, so how to find the minor of A? So minor we can actually get by deleting the row and the column. Okay, so make sure you have a big bracket, prepare a big bracket for them, because we are going to have the minor matrix, which means that you are going to calculate 9 minors together. So make sure to have a pencil and eraser ready for this one. Okay, so the first one, like I told you before, we need to have 9, right? So let me prepare the space for 9 first. Okay, so the first one will be when you delete the first row and the first column. So this is M11. Deleting first row, delete first column. So what you are going to get is 2, 4, 1, 3. So we are going to take the determinant for 2, 4, 1, 3. And then the second one, this is M12. So that means we are going to delete the first row as well as the second column. Okay. Okay, first row, second column. So they will become 3, 4, 1, 3. And then this is M13. So deleting first row, third column. So they will become 3, 2, 1, 1. And so on. Of course, you need to proceed until you get M3, 3. So this is the last one, M3, 3. Okay, so now get M21 first, deleting second row, first column. So second row, first column. Okay, let me erase the second row so that we can see them much more clear. Okay, so deleting the second row, first column, so 2, 3, 1, 3. Deleting the second row, second column, so delete the second column over here, delete them. So they will become 1, 3, 1, 3. And then delete the third column, so 1, 2, 1, 1. Okay, next we have to delete the third row. Okay, so deleting the third row, first column, because this is for M1, M31. So third row, first column. So 2, 3, 2, 4, third row, second column. 1, 3, 3, 4, third row, third column. Then it will become 1, 3, 3, 2. So that is how we are going to calculate the minus. And then of course, close bracket. And then for each of the entry, you need to calculate the determinant, which is AD minus BC. So for each of these, AD minus BC, 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 AD minus BC. Okay, so now once you calculate your determinant for each of them, okay, so this is basically what you will get for your minor matrix, which is 2, 5, 1, 3, 0, -1, 2, -5, -4. So yang ini kalau kata masih belum siap kira pun tak apa. Ambil dulu nilai ni. We want to learn the method first. Later on, we go into the calculation. Okay, so once you have your minor, okay, so you already have your minor. So that means you can easily find your cofactor. So what is the formula for the cofactor? That is -1 I plus j mij. So biasanya kalau kita nak tulis satu-satu tu dia nampak macam agak leceh kan? Okay, so sekarang saya bagi tips. How can you get the cofactor easily? Okay, so basically you need to draw a rectangle, a diamond shape ke rectangle ke whatever lah you call it. Diamond lah kot kalau bentuk macam ni. Draw a diamond. For the diamond, you need to times them with -1. So untuk diamond, you times them with -1. Then you can get your cofactor easily. So you simply write down everything else without the diamond first, and then the diamond position, make sure to times them with -1. Okay, so they will become 2, -5, 1, -3, 0, 1, 2, 5, -4. Do you see the diamond position over here? I change the sign. Okay, just in case tak nampak, jap kita delete sikit atas tu. Oops. Hailah. Highlight lah. Ini sekali lah. Okay, so this is 5. This is -5. So that is the first diamond position. This is 3. This is -3. This is -1. This is 1. This is -5. This is 5. So this is the diamond position. Of course, kalau nak guna formula macam tadi pun okay. Ni sebenarnya dapat daripada formula. Bila saya dah sure siapa odd, siapa even, so lagi senang lah untuk saya kira benda-benda ni. Okay, so now I already have my cofactor, then I need to find my cofactor transpose. Okay, so adjoint is the cofactor transpose, so I'm gonna write this one first but with a T, and then later on I'm gonna transpose them. Okay, so we are going to change from row 1 to become column 1, row 2 to become column 2, row 3 will become column 3. Okay, so adjoint is the cofactor transpose. So make sure to write down the cofactor first with the transpose, and then transpose it, and then that is actually our adjoint. Okay, so again, I repeat, how to calculate the adjoint? You need to find the minor, the cofactor transpose, and that is our adjoint. So there are a few steps that we need to do. Okay, so let us try to do another one. For example, 3. Okay, so we have P. P is 1, 2, 2, 2, 10, 5, 1, 3, 3. Find the adjoint of P. So again, I repeat, adjoint. That means you have to know what is the cofactor transpose. So to get the cofactor transpose, I need the cofactor. To get the cofactor, I need the minus. Okay, so we are going to start with the minor. Okay, so delete the first row, delete the first column. Okay, so we got M11, M12, M13, M21, M22, M23, and then M31, M32, M33. Okay, so M11, delete first row, delete first column. Okay, first row, delete them. And then first column, you delete this one. So you are going to get 10, 5, 3, 3. Okay, and then M12, that means delete first row, second column. Okay, so now delete the second column. We are going to get 2, 1, 5, 3. 2, 5, 1, 3. Okay, and then deleting the third column. So we are going to get 2, 10, 1, 3. Okay, so repeat for M to 1. But now we have to delete the second row. So let us erase this a little bit. Okay, so deleting the second row. And now delete the first column. So we are going to get 2, 2, 3, 3. So that is M to 1. And then you delete the second column. So 1, 2, 1, 3. Okay, so now deleting the third column, we are going to get another 1, 2, 1, 3. Okay, so now the last one, M3, 1. Deleting third row, first column, so it will become 2, 2, 10, 5. And then deleting the second column, 1, 2, 2, 5. And then we are going to delete the third column. So we are going to get 1, 2, 2, 10. So that is our minor matrix. Nampak macam semak lah pula tulis M21, M22 tu. Tak pernah nampak kot nilai dia kan. Okay, never mind. Right, so now for each of them, of course, we have to do AD minus with BC. So AD minus BC, AD minus BC, AD minus BC. Okay, so let us go through one by one. 10 times 3, so 30. 30 minus 3 times 5, 15. So 30 minus 15, so this answer is actually 15. Okay, so this one over here, 2 times 3 is 6 minus 1 times 5. So 5, 6 minus 5, so this answer over here is 1. 2 times 3 is 6. 1 times 10 is 10. So 6 minus 10, so this is negative 4. Okay, and then 2 times 3 minus 2 times 3. So this is actually equal to 0. Okay, and then we have 1 times 3 minus 1 times 2. So 3 minus 2. So the answer over here is 1. And then 1 times 3 minus 2 times 1. So 3 minus 2, which is exactly equal to 1 again. Right, so now another AD minus BC. So 2 times 5 minus 2 times 10. So we got 10 minus 20. So this is negative 10. Okay, and then 1 times 5 minus 2 times 2. So 5 minus with 4. So this is exactly equal to 1. And then 1 times 10 minus 2 times 2. So 10 minus 4. So this is equal to 6. Okay, mari kita tengok betul tak? 15, 1, negative 4, 0, 1, 1, negative 10, 1, 6. Okay, everything is correct. Okay, so now I already get the minus. Okay, so now we have to obtain the cofactor. So like I told before, the easiest one is you do something with your diamond position. So let us highlight the diamond position. Boleh lah guna highlight. Highlight the diamond position. Nanti sikit nak guna highlight. Okay. So now, let's see what happened to the diamond position. You times them with negative 1. So it will become negative 1. 0 times negative 1 is still 0. 1 times negative 1, so it will become negative 1. 1 times negative 1, again that will become negative 1. Okay, so we already changed the diamond position. So minor to cofactor, you simply times them with negative 1 times negative 1. So minor cofactor. Okay, so done with this. So now let us proceed with the cofactor transpose. So I want to obtain the adjoint. I have to write down the cofactor transpose. Okay, so adjoint, copy down everything. Don't forget transpose. Okay, so now we are going to change from row 1 to become column 1, row 2 to become column 2, row 3 to become column 3. So make sure you write them one by one. Take the first row, write them down as the first column. Take the second row, write them down as the second column. Take the third row and write them down as the third column. So do it very, very careful. And your final answer will be 15, -1, -4, 0, 1, -1, -10, -1, 6. So that is our adjoint. Kenapa adjoint A, adjoint B? Ha ha ha. Masa copy lupa nak delete. Adjoint P. Kecil lah tu. Okay, done. Right, so let us proceed with example 4 now. Find the inverse of B. So B is 1, 3, 2, 0, 2, 2, -1, -2, -1 and 0. Okay, so the formula, how to calculate the inverse. So B inverse is 1 over determinant of B adjoint of B. Okay, so now I have to find B inverse. So that means firstly, let us calculate the determinant of B first. Okay, so why do I need to calculate the determinant of B? Because if the determinant of B is equal to 0, I don't really need to find everything else because I don't have any inverse. So that's the reason why we have to calculate the determinant first. So determinant tu yang akan decide sama ada kita ada inverse ataupun tidak. Kalau kata determinant sama dengan kosong, tak payah kira lah benda lain tu. Sebab memang tak akan ada inverse. So that's the reason why you have to calculate your determinant first. Okay, so choose any rows, any column that you want to expand and that will be your determinant. So pilihlah mana-mana. Saya rasa saya pilih first row kot kalau tak silap saya. Sekejap saya check balik. Yes, I did choose. First row. No. I miss out the sign. This one should be 1, 2. This one should be 1, 3. Masa saya copy, saya pun nak tukar. Tak apalah, terima je lah. Okay, so A11, A12, A13. So I'm using the first row. So C11, that will be okay. This one, sorry, but please change it to C12 and then another one is C13. Masa saya copy, saya lupa nak ubah nilai. Sorry, tak sengaja. Okay, so now from here, again, this is M12, this is A12, 1, 3, 1, 3. Okay, my bad. Right, so change from cofactor to minor. So C11 is M11, C12 is negative M12, C13 is positive of M13. Okay, so we are using the formula Cij equal to -1 I plus j Mij. So that is the reason why you either have something with positive or negative. Okay ke macam tu? Ya Acik lah tu. Nak buat macam mana? Okay, so now let us substitute the value then. So A11 is 1, A12 is 3, A13 is 2. So substitute the value in. So 1, 3, 2. And then since I have negative for M12, I bring them in front. So that is why you see the negative sign. Okay, so M11, we are going to delete the first row, delete the first column. So we are going to get 2, 2, -1, 0. And then deleting first row, second column. So that is how you end up with 0, 2, -2, 0. and then deleting the first row, third column. So that is how you end up with 0, 2, -2, -1. Okay, so one thing that you should keep in mind is that this symbol over here, they should be absolute. That mean dia kena garis. Dia tak boleh pakai petak. Kalau pakai petak ini salah sebab petak adalah untuk matrices. This one we are going to calculate the determinant, therefore you should use those line. So pastikan kena pakai line tu lah. Okay, and then of course AD minus with BC, so A times D minus with B times C, so 2 times 0 minus 2 times -1, and then AD minus BC again 0 times 0 minus with 2 times with -2, and then 0 times -1 minus with 2 times with -2. So simplify them a little bit. So you are going to get 1 times 2 minus 3 times 4 plus with 2 times 4. So the answer for this will be -2. So 2 tolak 12 tambah 8. So 10 tolak 12 lah. We are going to get -2. Okay, so since the determinant is not equal to 0, that means B inverse does exist. Okay, so since I know B inverse does exist, so let us calculate what is the adjoint of B. So to get the adjoint of B, we have to start from the minor. So calculate the minor first. Find the cofactors, transpose them. Once you have your adjoint, then you can easily substitute into the formula to calculate the B inverse. Okay, so I give you a few minutes for you to calculate the adjoint. I think 5 minutes will do. Please calculate the adjoint. Okay, so calculate the adjoint. And then with this one, we are going to proceed with the property part. Oh, the loading. Okay, if you 5 minutes, 5 minutes until 8:40. Tadi lupa. So make sure to start from the minor, cofactor, and then cofactor transpose. Baru adjoint. Okay, 5 minit sebab nak kira tu licih kak. Sementara tu main saya edit ni jap. Semua orang okay ke tu? Are you guys doing good? Okay ke? Ke tengah ada masalah? Or do you need more time? Perlukan tambahan masa ke? Kot lah nak cari satu persatu tu lambat sikit kan. Nak tambah masa boleh juga. Yang lihat saya terlepas. Bukan terlepas apa. Terlupa sebenarnya. Kelas start pukul 8 hari ni. It's already 8:40. How was it everyone? Siapa yang dah dapat adjoint dia? Kalau tak saya bagi masa kecederaan. Masa kecederaan untuk kira. Bukan masa kecederaan. Belum lagi. Okey. Sekejap. Abel dah. Elisha belum lagi. Zahir Husna dan. Laju. Okey. Ada yang belum lagi. Saatlah kita tunggu sekejap. Sekejap Abel dengan Zul Husna. Zai Husna. Tak tahulah kenapa. Saya kalau baca nama orang ni mesti salah. Okey. Saya tunggu sekejap sikit lagi. Bagi orang lain bersiap juga. Nanti diorang nak proceed payah pula. So kita proceed sama-sama sekejap lagi. Okay, siapa lagi? Jeng 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 jeng. Okay, tak apalah. Sementara tu, cuba check dulu minor, cofactor. Tengok dapat sama tak. Minor tu lah yang penting. Sebab minor tu yang akan decide jawapan betul ke salah. Betul macam mana. Tak dapat masukkan jawapan. Dah ada. Okay, so now. Right, so we have to calculate the minor. So let us start with deleting first row, first column. Okay, so 2, 2, -1, 0. So that is by deleting first row, first column. Delete first row, second column, 0, 2, -2, 1. Delete first row, third column, so 0, 2, -2, -1. So that is deleting first row, third column. And then proceed second row, first column. So they will become 3, 2, -1, 0. Deleting second row, second column. So it will become 1, 2, -2, 0. Deleting second row, third column. So 1, 3, -2, -1. And then of course we need to delete third row first column 3 2 2 2, third row second column 1 2 0 2, deleting third row third column 1 3 0 2, and then close bracket. And then for each of them, you have to calculate AD minus with PC. So for each of them, kena kira lah AD times with PC, ADBC, 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 ADBC. Okay, so you times for each of them and then you are going to get your minus, which is 244, 245, 222. Okay, so firstly, let us check the minor first. Do you get the same answer with me? Minor? Sama? Tak sama? Okay, tak okay? Yes, okay, sama. Right, so now let us calculate the cofactor. So cofactor, we simply need to refer to the diamond position. You times them with -1. Okay, so they will become 2, -4, 4, -2, 4, -5, 2, -2, 2. So that is cofactor. And then to calculate the adjoint, we simply need to do cofactor transpose. Okay, so I transpose them straight away. So dah nampak tak ada T kat belakang kan? Sebab saya dah transpose siap-siap dah. Tadi sebab baru nak belajar adjoint. Sebab tu kena ada cofactor yang transpose lah. Tapi kalau dah biasa boleh tulis macam ni terus. Kalau nak transpose terus, tak perlu tulis T kat belakang lah. Sebab ni dah transpose lah. Okay, so adjoint 2, -2, 2, -4, 4, -2, 4, -5 and 2. Okay, so now let us go back to the formula for the B inverse. B inverse is 1 over determinant of B times with adjoint of B. So determinant of B is equal to -2, right, just now. And adjoint is that matrix over there. So we are going to substitute into here. So we are going to get 1 over -2, 2, -2, 2, -4, 4, -2, 4, -5, and then 2. And then of course, we are going to take this constant. We are going to times them with each of the entry. So you're going to times with each of the entry. So times them and simplify. So B inverse will become -1, 1, -1, 2, -2, 1, -2, 5 over 2, and then -1. So this is our B inverse. Okay, so I think we are done with the adjoint method. Okay, so now let us go to the properties of the inverse matrix. Okay, the first one, if you have A inverse and then you take the inverse of that A inverse, then they will simply become A again. So if you inverse for your A will be A again. Okay, so A transpose, if you want to calculate the inverse for the A transpose, that will be equal if you are calculating the A inverse first and then you transpose your answer later on. So they will be equal. Either you do the transpose first and then calculate the inverse later on, or you inverse them first and then transpose them. Okay, C. If we have AB inverse, so that means for this one, you are going to calculate AB first, A times B first, get what is the value for A times B, and then you inverse that product. That will be equal if you are doing B inverse. So calculate the inverse for B first, and then you calculate the inverse for A. You times them both. So that is actually equal to AB inverse. So yang ni sebenarnya boleh nampak kan masa AB transpose pun macam ni juga kita kena pusingkan dia. Okay, so now determinant of A inverse. So this is actually equal to 1 over determinant of A. Okay, so why is that? That is basically because A multiplied with A inverse is equal to I. Identity matrix. So A multiplied with A inverse is equal to I. So if you want to calculate your determinant, you can do something like this. So determinant A inverse. So this is determinant of I. Okay, determinant A inverse. So you can actually use the property. So this is determinant of A inverse. Determinant of I is simply equal to 1. So that is how you get determinant of A inverse is 1 over determinant of A. Okay, so this is basically how we obtain the fourth properties. Okay, let's go to the next one. Okay, so now we are going to use the second method, which is using the property AB equal to KI. So sometimes they will give you two matrices, so matrix A and matrix B. They ask you to times them first, so they ask you to find what is AB, hence find the inverse of A, or hence find the inverse of B. So for this kind of question, you have to use the property to calculate the inverse. Okay, so kalau untuk property dia mesti kena bagi dua matrix Dia memang minta kita darab dua matrix dulu. And then when you times those two matrix, you are supposed to get some constant multiply with I. So you will have something like K0, 0, 0, K0, 0, 0, K. It will definitely be in this form. So kalau kata soalan tu minta guna property, dia mesti dalam bentuk ni. Mestilah. Okay, next. Right, so inverse by using property, if AB equal to BA and that is equal to I, so that means B is equal to the inverse of A and A is actually the inverse of B, because when AB is equal to I, then it simply means that A inverse is equal to I, therefore B is A inverse. If we have BA equal to I, B equal to I. B inverse equal to I. So A will be equal to B inverse. Okay, however, if AB is equal to alpha I, then A inverse is 1 over alpha multiplied with B, and B inverse is 1 over alpha multiplied with A. Okay, so AB is equal to alpha I. Okay, let's say if we want to find A inverse, right? So I will times with A inverse. So A inverse AB. So this is A inverse alpha I. A inverse multiply with A, that is I. So this is exactly B. So this is equal to alpha A inverse. Okay, so we want to make sure we have A inverse as the subject. So A inverse will become 1 over alpha B. So yang ini boleh bahagi sebab alpha tu constant saja. Boleh bahagilah. Ataupun senang cerita kita darab 1 over alpha. Okay, so similar thing will happen over here. If let's say I have AB equal to alpha I, if I want to get B inverse, then I have to times B inverse at the back. So AB B inverse, so this is alpha I B inverse. Okay, so one thing that you should keep in mind with matrices is that when you times, it should be in the correct position. So for example, over here, I times at the back, so this one also at the back. Mesti kena position yang sama bila kita darab tu. Okay, so B times with B inverse, that is equal to I. So this is A equal to alpha B inverse. So that means B inverse will be equal to 1 over alpha A. Okay, so that is how we can derive this formula. Okay, next. Given that A is 4, 1, 2, negative 2, 3, 1, negative 1, 3, 1, and B is 0, negative 5, 5, negative 1, negative 6, 8, 3, 13, negative 14, find AB as a single matrix, deduce A inverse and B inverse. Okay, so you have to times A times with B. So we are going to separate the rows and the column. Okay, so this one is 4, 1, 2, negative 2, 3, 1, and then negative 1, 3, 1. The column is 0, negative 1, 3, negative 5, negative 6, 13, 5, 8, negative 14. Okay, and then basically you should times them in order to fill in the table at the back. So lah. So 4 times 0 plus 1 times -1 plus 2 times with 3. So we got -1 plus 6 over here. Okay, so this one over here is -3 plus with 3. And then you have -3 plus 3 again as well. So over here, -20, -6 plus 26. And then this one is 10 minus 18 and then plus with 30. And then this one over here is 5 minus 18 and then plus with 13. Okay, so this one over here, 20 plus 8 minus 28. And then we have -10 plus 24 minus 14. And then the last one over here is -5. And then plus with 24 minus with 14. Okay, so when you do that, you should be able to see that the value for A times B is actually equal to 500, 050, 005. Sekejap. Betul? Semua okey kan? Semua betul lah. Okay, so AB is 500, 050, 005, which means that AB is exactly equal to 5i. So this is my K. Okay, so AB equal to 5i. How are we going to get A inverse? Okay, so AB equal to 5i. So you times with A inverse. So A inverse AB equal to A inverse 5i. Therefore, B is equal to 5A inverse. Therefore, A inverse is 1 over 5B. So that is our A inverse. So basically, in order to get B, we have to times with B inverse, the same method, just like what we did earlier. Miss, row 2, column 3. Sekejap. Row 2, column 3. Bukan dapat 14 ke? Row 2, column 3 yang ini kan? 1 darabkan dengan -14. So sepatutnya dapat -14 lah kan? Tengok boleh Hakim? 1 kali -14, so sepatutnya dapat -14 kat situ. Okay. Right. Now, where did I stop? B inverse. Okay, so we are going to do the same thing and then we are going to calculate the B inverse. So kita guna method yang sama macam ni lah. Okay, so now let me show you what happened to the A inverse first. Okay, so A inverse is 1 over 5 times with B. So you simply copy down the matrix B over here. So copy down the B and then you times everything with 1 over 5. So that is your A inverse. Okay, so how to deduce the B inverse? Okay, so AB is equal to 5i. So you times with B inverse at the back. So AB B inverse is equal to 5i B inverse. So B times with B inverse is equal to I. So this is A equal to 5B inverse. Therefore, B inverse is equal to 1 over 5A. Okay, so B inverse is 1 over 5A. So you're gonna substitute with A inside here. And then the final answer is this one. Okay, so it's A inverse, B inverse. Tu Hakim tu jumpa tak nilai dia? Bukan 14 tapi -14. Jumpa tak tu? Okay, next. I think that's all for this lecture. Yep, that's all. So I'll see you guys later. So kejap lagi saya bagi link untuk Google Meet macam biasalah. So kita masuk dekat Google Meet. Jumpa kejap lagi. Bye-bye semua orang.